In this video tutorial, I am going to discuss about this important exam question, that is why hypoalbuminemia leads to development of edema. Remember, edema is a condition in which there is increased volume of interstitial fluid. Or in short, you can call it as a ISF. So to understand about the edema, we have to first understand that how interstitial fluid is being managed. So to understand that how interstitial fluid is managed, let's suppose this is the capillary. Inside the capillary, we have a plasma. And outside of the capillary, we have an interstitial fluid. Remember, interstitial fluid is the fluid between the intercellular space or the fluid between the cells. Now, there is a complex play of various forces between plasma and interstitial fluid, which is called as a Starling forces. We will not discuss about the Starling forces in detail over here, but the ultimate effect of the Starling forces is that inside the plasma, inside this capillary, we have a plasma, and so because of that there is a continuous hydrostatic pressure. This hydrostatic pressure is of a pushing in nature. That means it pushes the fluid from the capillary towards the interstitial fluid side. And there is one more pressure which is called as a osmotic pressure. It is also called as a oncotic pressure. In the plasma, we have a albumin, which is the main plasma protein, and because of the albumin, this osmotic pressure is created. This osmotic pressure is pulling in nature. That means it pulls a water from this interstitial fluid side towards the capillary side. Now normally the hydrostatic pressure is slightly higher than the osmotic pressure. So because of that pressure difference, there is a net filtration of plasma into the interstitial fluid. So there is a continuous inflow of this interstitial fluid. So let's say this is the interstitial fluid. But in normal person, what happens? This interstitial fluid is continuously drained by a lymphatic system. So because of this lymphatic system, this interstitial fluid does not get accumulated, and some optimum level of interstitial fluid is being maintained. Now you can easily understand that in which condition this interstitial fluid volume will increase. So the first condition is if there is a blockage in the lymphatic system, if there is an increase in the hydrostatic pressure, or if there is a decrease in the osmotic pressure. So these three major conditions leads to increase in the interstitial fluid volume, and we know that increase interstitial fluid volume is called as a edema, right? So now coming to the question that why hypoalbuminemia leads to development of edema. See, hypoalbuminemia means there is a decrease in the albumin concentration. And we know that albumin is responsible for the osmotic pressure. So decreased albumin concentration leads to decrease in the osmotic pressure. And by the way, remember, osmotic pressure is also called as the oncotic pressure. And we know that whenever there is a decrease in the osmotic pressure, it leads to increase in the interstitial fluid volume. So there is increased interstitial fluid. And increased interstitial fluid is nothing but the edema. So this is how edema occurs, and generally most of the students state only this much reason for the development of edema. But remember, there is more in the story. See, what will happen when there is an increased interstitial fluid? So this interstitial fluid, it is coming from where? Obviously it is coming from plasma. So whenever there is increased interstitial fluid, it leads to decrease in the plasma volume. Why? Because plasma itself is being filtered and giving rise to interstitial fluid. So there is a decrease in the plasma volume. And whenever there is decrease in the plasma volume, it leads to decrease in the blood volume. And whenever there is decrease in the blood volume, it leads to activation of one very important hormonal axis, which is called as a renin-angiotensin aldosterone system. In short, it is called as a RAAS. This renin-angiotensin aldosterone system activation leads to increase sodium and increase water retention. Now this increased sodium and water retention has two major deleterious effects. See, what will happen if there is increased sodium and water retention? This retained water, it will go to where? It will come to the plasma. It will go to the plasma. So what will happen? There is a restoration of plasma volume, or you can say there is increase in the plasma volume. Because of this increased plasma volume, what will happen? There is increased congestion of water over here. So it leads to increase in the hydrostatic pressure. So it leads to increase hydrostatic pressure. And we know what will happen if there is an increase in the hydrostatic pressure? It leads to increase in the interstitial fluid. So it leads to increase interstitial fluid. So this one vicious cycle comes into the action. Now story is not even stopping over here also. There is one more mechanism. See, if there is more of the water retention, what will happen? This water, we know that it is coming to the plasma. And there is already less albumin concentration, right? So here this albumin, whatever less albumin is there, it gets further diluted by this increased water retention. So increased water retention, it can further lead to decrease in the albumin concentration. And what will happen if albumin concentration is decreased? That we all know. It leads to decreased osmotic pressure and increased interstitial fluid. So it again worsens edema. So this is a second vicious cycle. So remember, decreased albumin concentration, it directly causes edema. It indirectly, by this two vicious cycle also, it can further worsens the edema. So now you know the complete picture that why hypoalbuminemia leads to development of edema. Now the one last bonus point that I want to discuss is that in which conditions this hypoalbuminemia occurs. There are so many conditions in which hypoalbuminemia occurs, but there are three major conditions. The first is liver cirrhosis. So in liver cirrhosis, what happens? Hepatocytes are destroyed and replaced by the fibrous tissue. And albumin is synthesized by the liver hepatocyte. So you can easily imagine what will happen in the liver cirrhosis. There is a decreased synthesis of albumin, so it leads to hypoalbuminemia. The second common condition is the severe malnutrition known as a Kwashiorkor. In the Kwashiorkor, there is a protein energy malnutrition with a special emphasis on the protein malnutrition. As protein is not there in the diet, so liver cannot find raw material for the synthesis of albumin. Okay, so in this condition also hypoalbuminemia occurs. And the third condition is the nephrotic syndrome. In the nephrotic syndrome, what happens? Liver is completely normal. So liver is synthesizing normal amount of albumin. But that normal albumin is getting lost through the glomeruli. So that condition is a nephrotic syndrome. So in nephrotic syndrome, what will happen? Albumin is lost through the urine. And so because of that, there is a decrease in the albumin concentration. So these three clinical conditions are a main reason for the hypoalbuminemia. And we know that hypoalbuminemia leads to development of edema. So this question, that is why hypoalbuminemia leads to edema, it can be modified. Like liver cirrhosis can lead to edema, or Kwashiorkor lead to edema, or nephrotic syndrome can lead to edema. So in all those questions, the answer will remain same. So that's all for this video. I hope that all the concepts are clear. If you still have any query or confusion, please write it down in the comment section below. Thank you.